Alright students, let's look at this question here which was taken from the year 2018, your H2 Math A-Level Paper 2 question 3. So a solid cylinder has a radius r, height h, and a total surface area of 900 square centimeters. Find the exact value of maximum possible volume of cylinder. Find also the ratio of r to h that gives the maximum value. Okay, maximum volume. Let's look how we can do this proficiently. Now, I think the idea here is fairly straightforward in the sense that you need to be able to tell there are two, there are two variables typically, and there's a fixed condition here which can relate both of them. All right, so these are important concepts. The variables here are the r and the h. Total surface area is 900 square centimeters. So I'm just gonna solid cylinder, right? So it's a closed cylinder. Find the exact value of maximum possible volume, right? So here the maximum possible, the volume of the cylinder is pi r square h, no an issue. Our problem here is two variables. All right, you need to change this to only one, so you try and relate them by using this total surface area. So we know that total surface area is 900 square centimeters. So total surface area will be pi r square plus 2 pi r square. So meaning to say I just take this, and after which we just need to add the curved surface area here. Okay, so how do we know the curved surface area? What usually I'll tell students is actually just remember the curved surface area, you just take the circumference here. All right, so it makes sense. You take this circumference here, multiply by the height, it will give you the curved surface area. So there's one way for you to probably like memorize the curved surface area of a cylinder. Okay, so you take because this net here is actually a rectangle. Okay, so essentially here what we do is 2 pi r multiplied by h equals 900. Okay, so this is how you relate both of them. You essentially relate them, and because we want to change, I think changing h would be good. Changing into r, so making h a subject will be good. So h will be 900 minus 2 pi r square over 2 pi r square, 2 pi r. So from here, I'm going to just take 1 and sub into 2. So sub 1 into 2. And what we'll get is the volume will just be pi r square 900 minus 2 pi r square over 2 pi r. Alright, so this is once done. Cancel off the pi, cancel off the r. What is left here is actually just 900 r minus 2 pi r cubed over 2. So of course we can further simplify to 450 r minus pi r cubed. So from here we need the maximum value. So dVdr is 450 minus 3 pi r square. All right, then we could just quickly do a second derivative test just to make sure that. So this is obviously negative since r is positive, so hence v is maximum. Okay, that's it. I just quickly check if this is indeed a maximum volume. So once this is done, what we do is add stationary value. dVdr is 0. So in this case here, 450 equals minus 3r square. 3 pi r square is 0. Okay, so this whole thing here is 0. So then what we're going to do is just change it. So make r the subject. We need to find that. So 450 divided by 3, that will give us 1 to 150. So 450 divided by 3 pi square. So this is r. Okay, it. So that's dVdr. That's it. Now what that is done, so find the exact possible maximum volume of the cylinder. So possible maximum volume, just key to V here. So hence maximum would be 450 square root 150 pi minus pi 150 pi cube. All right, so this case here will be 450. I think 150. Okay, I'll just leave it first. 150 pi. This is 150 pi 150 pi 150 pi. So just know that this guy here, you could merge it to 150 pi, then you could just cancel it out. All right, so if you're, this is, I think, one of the easiest way to do this kind of manipulation. So this is done. So cancel this off, 150 there. That will be essentially 450 minus 150, maybe 300. 150 over pi. Okay, so 150, I'm pretty sure you could also divide by, could you rationalize 150? You could, 150 could divide it by 25. So 360, 25 pi. So this case here, 300 square root 25. So this case will be times 5 cubic centimeters. All right, that's how you find V maximum. I prefer it in this form here. Okay, this looks better. So that's your V maximum. Find also the ratio of R to H that gives the maximum volume. Okay, great. That's not too bad. From here, what I'll suggest is, okay, I'll just go copy this, and this is R to H. So this is the case here. So H is this. So I'll need to find the ratio of R to H. H is equal to this expression, and when V max, this is the R, right? So I know that R square is 150 over pi. So I'm probably going to substitute R square in first. Could I square both sides? I could square both sides if I want to, but I'm just gonna, actually I could square both sides. That would be good. Square both sides will probably help because there are too many things going on here. So I deal with, I rather deal with R square. So 900 minus 2 pi R square over 2 pi R square below. So I'm just going to replace R square in. That'll be easier. So that'll be 150 pi. And then this will be 900 minus 2 pi 150 over pi square. Then that'll be 4 pi square 150 pi. Great. So the top here, what is left is 600 square. The bottom will be left with 4 times 150, 600 pi. Great. I think this is good. So essentially, what we get is 150 pi, 600 pi. So this is just 150 to 160. Okay, so this case I'll get 1:4. On hindsight, just be careful. This is R square to H square. So in other words, this will be R square. So R to H will just be 1 to 2. Okay, probably not the easiest way to manipulate this. So this is R square dot H square, the ratio here. Just be mindful of that. I should have squared it, I think. I think we could just use normal manipulation. It will also work, okay? So if you have any question, please do let us know. Maybe I'll just write down the typical way of solving it without squaring it. What I could do is just multiply by 2 pi R on the other side. So that I can get rid of this. So this will just be, yeah, then this will be quite okay. Okay, so it's a ratio. So now I can just key in 150 pi. Yeah, this is okay. So what I'll get is 300. This is 900 minus 2 times 150. That will be 600. Okay, so that's how we do this question here proficiently. If you have any questions at all, please let us know, and I will see you in the next question.